Lesson 117, using trigonometric ratios. Now, can you please all say trigonometric? Come on, you can do it. Trigonometric. All right, that's going to have to do. All right, so we're going to draw our right triangle because we use all these trig ratios or with right triangles. Okay, so we'll call A, B, our right angle is C. Across from angle A, we'll call little a. Side across from B, we'll call little b. And the hypotenuse, we'll call C. C is the hypotenuse. B is, we call this the leg adjacent to angle A. We can also call it the leg opposite angle B. And then little baby a is the the leg adjacent to angle B. Or sometimes we say it's the leg opposite angle A. So we have these trig ratios. We're just going to go over, 6 of them. But the first 3 are the main ones. We have what's called the sine of angle A. Now, for shorthand, we just do SIN, and it's still read sine of A. And that's going to be the opposite leg over the hypotenuse. So, if we look at A, we're going to go the opposite of A is little a over little c. So the sine of angle A is A divided by C. Then we have the cosine of angle A, and we still say cos, actually we can say cos, of A, and that is the adjacent over hypotenuse. So the adjacent leg of angle A is the side B, so it's little b, over C. And then the tangent of angle A, and we do tan A, and that is opposite over adjacent. Opposite over adjacent. So we look at angle A, opposite of A is little a, adjacent to angle A is B, so it's A over B. Also, the tangent is also just sine divided by cosine. And when you take those fractions, AC divided by BC, keep a change and flip it, and you get A over B. So a couple of ways that we can remember how to remember this is Sohcahtoa. So Sohcahtoa. That's one way. I've also seen it written Sohcahtoa. So this reminds us that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So the sine is opposite over hypotenuse. That's where the SOH. The cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now we have the inverse functions of all of these. So we can do the inverse functions, and that's just where we do the reciprocals. So they're all just reciprocals. So if I wanted to do the reciprocal of the sine, that's called the cosecant of angle A. So we write cosecant as CSC of angle A, and that is the hypotenuse over adjacent, or 1 over sine of A. Hypotenuse over opposite, which is C over A. And then if we want to do the inverse of cosine, that's called the secant So if we're trying to find the secant of angle A, we do that SEC, and that's just 1 over cosine, which is the hypotenuse over adjacent, or C over B. And the last inverse is cotangent. Of angle A, and we use COT, and we still say cotangent, and that's just 1 over tangent, which is adjacent over opposite. So that's B over A. Now this is all in relation to angle A. You can also do all of these 6 different trigonometric ratios with angle B. So let's just give an example here. Example 1. We have a right triangle. We're going to draw it just like we did in our example, in our notes. ABC, little c, or the hypotenuse, is 25, CB is 15, and AC is 20. Find all 6 trigonometric ratios, we'll just call it trig, for angle A. So the sine of A is opposite over hypotenuse. So A, the opposite is 15, divided by 25, and then we reduce to 3/5. The cosine of A is adjacent over hypotenuse, which is angle A, adjacent is 20, divided by hypotenuse, which is 25, which reduces to 4/5. Then the tangent of A is opposite over adjacent, Sohcahtoa. So opposite, so 15 over 20, or 3/4. And then we just do the reciprocals. So the cosecant is the inverse of sine. So it's CSC of angle A. It's just going to be 5/3. The secant of angle A is 5/4, and the cotangent of angle A is 4/3. Okay, we're going to do one where we have to find the missing side length. So, find a missing side length. Now, we're not going to have 2 sides. If we did, then we could just use Pythagorean theorem. It's a right triangle. This is 17, and then the angle that's right next to 17 we'll say is 32 degrees, and then we have x. So if you notice, we have both legs. Whenever we have both legs given, one's x and one's 17, we want to use tangent. So we're going to say tangent of 32 equals, now it's toa, opposite over adjacent, so it's x over 17. So if I multiply both sides by 17, I get x equals 17 tangent 32. And when you use your graphing calculator, you want to make sure that the mode that you're in degrees. So then we can go x is approximately 10.62. Just find the tangent of 32 and multiply that by 17. So we're going to do one more example. This time we're going to find a missing angle. So these are all type of problems that you're going to have in your homework. Find the missing angles. So let's do more than one. So we're going to have one leg is 12, one's 19. The angle opposite leg 12 is A. So we actually want to find the measure of angle A. So we have, here's A. We have the opposite and the hypotenuse. And opposite over hypotenuse is the same thing as the sine of A. So we can say the sine of A equals 12/19. So when we want to find what the angle measure is, we take the sine inverse of both sides. So A is going to be the sine inverse of 12/19. And you have that is just the second sine button, so the yellow button that says second, and sine. That'll give you the sine inverse. You put 12 divided by 19 in the parentheses, and you get approximately 39.17 degrees. And to the nearest degree, that would just be 39 degrees. And that's the end of the lesson.